Today's project is getting Wi-Fi out to the garage. My house has Wi-Fi. We actually have fiber to the house and good service, but the garage is separated. So here's my house, and just for reference, here's the radio room over here. The fiber optic cable comes in and drops down into the living room, and there is a router there, and that router has Wi-Fi. And that Wi-Fi provides coverage to a good part of the house. But the house has a lot of concrete and metal in it, so the signal actually doesn't penetrate that far. In fact, in the radio room, to have reliable service, I had to put another router over here. And this was a Linksys router that I set up in repeater mode. I ran another Ethernet cable, twisted pair, through the crawl space in the ceiling and dropped it down, and then I've got Wi-Fi coverage in this part of the house as well. Now, this doesn't help me for the garage. So originally in the garage, which is where the workshop is, I had a PC, and it was running Windows 7, and one of the features that was introduced in Windows 7 is the ability to set the computer up as a Wi-Fi repeater, even with one Wi-Fi port, whether it's a USB dongle or if it's a PCI card. That one Wi-Fi adapter could serve to both receive and relay Wi-Fi. So originally that's what I had. I had that set up, and the little dongle part of it actually stuck out the side of the garage, and it was able to hear well enough from the living room that I could make the signal. The distance here is about 10 meters or so, or 30 feet. Not a huge amount, but again, the conditions make it a little bit more difficult. There is a porch that runs around the side of the house, and that porch has mesh on it, aluminum for the ceiling, and then screen mesh on the side, and then aluminum below it. So effectively, it's a RF shield on this side of the house, and that greatly attenuates the signal to the garage, even to the extent that when I have the doors to the patio open, I get better signal. So that's a significant barrier. I was just barely making it with this setup, and part of the reason that that setup worked so well is that it's a USB dongle that was hanging out the side of the garage. There's no loss from that dongle back to the computer. The signal is sent digitally from the point that it's received right to the computer, so there's no transmission loss in that line. Unfortunately, that computer died. While I was away, something must have happened. Maybe we had a power spike, although I had it on UPS and so on. That computer's dead, and with it Windows 7. And for the time being, I have a Raspberry Pi out there in the garage, which I'm using for various projects. Maybe you'll hear about that at some point. But this idea of sticking the dongle out the window just was not working as well with that setup. It's more involved to set up the Raspberry Pi to function as a repeater, although that also is possible. But I wanted to have a lot of flexibility in terms of having other like laptops or other computers in the garage and being able to hook up to the Wi-Fi network just anytime I wanted to, and move them around and so on. And devoting the Pi to that probably wouldn't allow me to do other things that I wanted to do with the Raspberry Pi. So I remembered when I was on my way back in the States, I picked up a Linksys blue box router, one of the common WRT 54 series routers. And originally I was going to give it to a friend to use for high-speed mesh. Unfortunately, I didn't have time to hand it off to him before I flew back to Madagascar, so it came with me in my luggage, and I more or less forgot about it until this happened, and I realized, oh, what I really need is to put another Wi-Fi repeater over in the garage, so that's what I did. The first step was to take my wireless router that I picked up for $3 at a secondhand store and make it into a wireless repeater. This isn't a capability that is inherently built in, or at least at that time, this is an older model, it wasn't built in. It did have the ability to take the connection coming in on the WAN port, for example, Ethernet, and share that over a Wi-Fi network, but it didn't have the ability to extend a network. So I found a use case very similar to what I was looking for on Lifehacker, and they go into a lot of detail about how to set up a Wi-Fi repeater. Their instructions actually are more complicated than it turned out to be. I had a much easier time than the article reflected. So first step there is to get a new firmware for the Wi-Fi router, and there are a few options available on the net. You'll find OpenWRT, DD-WRT, and a few others. I went with DD-WRT because I initially looked at OpenWRT because I'd heard of it. More of my friends are using that. It didn't have drivers for the specific model that I was looking at, whereas DD-WRT did. And the way to know that is to go to the DD-WRT site and to pull up the database, which lists all the models for which they've written firmware. And it's not only by model but by version number. So I looked at my router. It's a WRT54GS. In addition to the model, it's important to look for the version number, because even within a model, the capabilities of the router change and the firmware requirements change. So it is version specific. So under each version, not only is there some software to download that you'll flash, there's also a link over to the DD-WRT wiki. And the wiki is very helpful because it goes into step-by-step instructions on how to install the software and get things running, and provide some troubleshooting in case things turn south. For me, installing the new firmware was a matter of little more than rebooting the router a couple times and waiting the requisite amount of time for the new software to take hold. Those two items, though, are pretty important, and they go into a lot of detail about how to reboot the router. There's something that they refer to as the 30-30-30 reboot, which means holding down the reset button for 30 seconds, pulling the power out, continuing to hold down the button, putting the power back and continuing to hold down the button. And that's to flush the old firmware out entirely during the reboot after you've loaded. And then waiting the requisite amount of time for the new software to boot up and to take hold. And apparently either one of those operations, if you don't do it right, can brick the router. And there are ways around that using JTAG headers and so on, but probably don't want to get into that. I just followed the instructions and it worked perfectly, and it took me about 10-15 minutes, and I had effectively a brand new router. On the back of the unit are two swiveling rubber ducky antennas, and each of them screws into the back of the unit through an RPTNC connection. I pulled one of them off, and you can see the connection looking edge-on at it. When I took the plastic off of that antenna, I revealed a bit of coax, a shielded section, and then a piece of the center conductor that extended and functions as the actual antenna, and that's it. Each of the two antennas basically has that inside and nothing more. So, perhaps naively, I thought, well, why not just take that little antenna and stick it out the window? And to do that, I just need to extend the feed line. So I used some LMR 240 low-loss coax, which is designed for UHF-VHF work, and even if it wasn't ideal, it's what I had on hand, so that's what I used. And I mated it up to the piece of the antenna that I pulled out of the plastic. In order to maintain continuity for the shielding, I used copper tape to go from the braid on the LMR 240 essentially to the braid at the base of that antenna unit, and I put some heat shrink tubing over the end of it. There was no connection at the other end of the wire, so I just cut it flush and mounted a BNC connector on the end. The BNC consists of a few pieces that slide over the wire, and then a pin is soldered to the center connector of the wire, and the entire thing is compressed together, and that gives a good mechanical connection as well. The router doesn't have a BNC connection on the back, so I had to add one. Looking inside the router, you can see the
two antenna ports that come out the back, the RPTNC ports. One of them is mounted directly to the board. The other one is soldered to the board, but is fed by a coax cable that runs across the board. In later models, both are just soldered directly to the PC board. It was easy for me to go into that cable though, so I unsoldered the connector that's fed by the cable, cut the cable, and then spliced on a BNC connector. And it ran out the same hole that the RPTNC connector did before, except that hole was too large for the BNC to really hold in position with the nut that's on the BNC. So I had to make a little adapter piece of metal to hold it on the back. In order to push the antenna through the wall and have a bit of it sticking out, I needed to give it some protection, so I used a plastic milk jug, and I arranged it such that the coax wire goes through the cap of the milk carton, and there's tape on each side of it to hold it in place, and that should protect that little metal tip of the antenna. Here's the outside of the garage, and here is the look back towards the house to show the distance. Basically inside that door is the router. So here's the new router with the BNC connection on the back. The BNC connection runs up from there to two access holes that lead to the outside of the garage. They conveniently slant outwards so that if rain gets into them, it drains towards the outside. So I've got a number of different things running through them. So when I measure the connection strength with the garage door open and that door open, it's pretty good. But it turned out that the signal was not adequate to really maintain a consistent internet connection to the garage with the doors closed. Here's the outside view. I've taken the milk jug out from where it was, but it was in that port that's closer to us, and I have other things running out of those ports. I think part of the reason that it didn't work is that we have a small antenna located at some distance to the receiver, and you've got the attenuation of the LMR cable itself, the two BNC connectors, and the entire thing is a little bit jury-rigged. Also, the antenna orientation really couldn't be altered. It stuck straight out, so it was horizontally polarized, and that may or may not have been ideal. But the other thing that turned out to be a big issue was this plant behind us. This is an RF eating plant, and the amount of signal loss in the path going through this plant is amazing. So I had to figure out some way of getting around the plant and giving better gain. My solution to the gain issue was to make a cantenna. These are inexpensive antennas to make. It's essentially a long can with one end open, and towards the closed end of the can, a quarter wave antenna element. There are lots of plans on the internet. There are calculators such as this one that show you for a given size can how far back does the antenna have to be, how large does it have to be, and so on. A lot of the plans tell you to use a N connector, which is a great connector, a very low loss at gigahertz frequencies. Again, I didn't have one, so I used a BNC connector, which worked out okay. The BNC connector was connected up to the side of the can and fixed with coax seal and tape and so on to make a watertight connection. I also put plastic over the front of the antenna to keep it dry on the inside. The measurements are relative to the diameter of the can. The length of the can doesn't really matter so much beyond a certain minimal length. The longer you go, in fact, the more directional it becomes. So in my case, I took two cans. One was, I think, a chili can, and one was lentils. Emptied them out, cleaned off the paint from the inside because I was afraid that that might absorb some RF, and soldered them together, and that became the waveguide for my cantenna. That's a big Wi-Fi absorbing plant. When I tested the antenna down by the garage opening, I got a great signal from the house, quite usable, good throughput. But when I put an antenna behind that plant, I get very little signal. In fact, it goes down to something like 17% connectivity and drops out. No good. So here's what I came up with just temporarily. This works. Oh, it's a little strange. Here's the cantenna mounted on a tripod, and it's not pointed towards a house. It's pointed at that wall. It just happens that the reflection from that wall gives me a better signal than trying to shoot through the plant. So my next thought is, can I move the antenna to someplace where it has a clean shot at the house, given the run of cable that I have, only 2 meters long?
here's what I came up with. A cantenna on a stick. It's not the most permanent installation. That's really electrical tape holding it onto the stick, but it should work for the time being. The stick is mounted on the side of the garage and not the most permanent way. There's more room to raise that, maybe for other projects later. And the coax goes in through the little porthole on the side of the garage. But it's good enough to get me Wi-Fi out to the garage. We are out in the garage, and this is what we're looking at. The garage door is open, and it does matter. So we're getting 56% signal quality, a signal of minus 49, and a signal to noise ratio of 46. And the other connection is actually the cell phone that I'm using to film. Okay, well, that wasn't what I was expecting. I thought that signal would plummet somewhat because we were with the garage door down. We're not getting the full effect of the two antennas, which are both active and in diversity receive. So, okay, that's fine. If we're getting good signal quality with the garage door down, that's quite helpful. And just the throughput on devices, anecdotally, is fine. I'm able to stream video, which is probably the most intensive thing I would do out in the garage anyhow.
One technical nuance: when I originally set up the router, I set it up as a wireless repeater. The problem is that puts everything off that router on a separate subnet from the rest of your LAN. So the living room was on 192.168.1. whatever, whereas everything that I would connect to the router in the garage would be on a 192.168.3. something subnet. What I really wanted was a repeater bridge, which puts everything onto one subnetwork, and the connection is transparent through the router that's set up in the garage. So just to remark that that's a separate setting within DD-WRT. So that's my Wi-Fi project. I need to make the mounting a little bit more permanent, but I would say we're done. So 73 from Madagascar. This is 5 Romeo 8 Sierra Victor. Clear.